Good morning, geometry class, and I'm glad to see you all this morning. Hope everybody's doing well. Great job on your homework, so continue to get that homework turned in. Great job with that. Just want to make a quick announcement that today, after you do your pages, you'll need to take the checkup. So that'll need to be turned in. So after our few pages we're going to take, be sure to take the checkup, okay? And you'll be doing all those problems for the homework. Let's just quickly do a quick review. And so far we're learning coordinate geometry, and yesterday we learned a couple terms that we want to just kind of review. We looked at this, and this is called a coordinate plane. A coordinate plane, and then on a coordinate plane we have the vertical axis is called the y-axis, and the horizontal axis is called the x-axis. And you don't want to forget that. Very important for us to remember some of the terminology. Also, we want to know that 0 here, again, the 0 is called the origin. All right, so 0 is right where the perpendicular lines intersect. 0 is called the origin. Now, one of the other things that we learned yesterday was that these areas are called quadrants. Okay. There are 4 quadrants. We have quadrant 1, and they are counterclockwise, quadrant 1, quadrant 2, quadrant 3, quadrant 4. And so in quadrant 1, we know that both numbers will be positive, okay? To the left, in quadrant 2, we know we're going to have a negative and a positive. Quadrant 3, we're going to have negative, negative. And then quadrant 4, we're going to have positive, negative. So you want to understand where those numbers, okay, wherever these coordinates are located. Quadrant 1, both numbers will be positive. Quadrant 2, we have a negative and a positive. Quadrant 3, both numbers will be negative. And quadrant 4, we'll have the first one is positive and the second one is negative. Now, quickly, we have that these numbers here are called coordinates. We have the first term is x and the second term is y. And so when we're graphing these coordinates, always we're going to graph the x first. And so x, again, the number would be on the horizontal plane, and the y would be on the vertical plane. The first term, the x, okay, coordinate, is called the abscissa. And the second term, the y, is called the ordinate. The abscissa and the ordinate, okay? And so you want to be sure to remember those terms, very important. Yesterday we basically looked how to graph, and then we learned how to find the distance between 2 points, between 2 coordinates. And the key, what we learned yesterday was coordinates that have the same abscissa or coordinates that have the same ordinate, okay? You'll kind of review that if you want to look at page 5 with me again. And so the distance between any 2 points in the coordinate plane by using the absolute value of a number. So the distance between 2 points having the same y-coordinate, all right? So if they have the same y-coordinate, the formula is d equals the absolute value of the difference between the x2 minus x1, and if we have the same x-coordinate or the same abscissa, then we will go y2 minus the absolute value, y2 minus y1. So again, these, make sure you need to memorize those, okay? We're going to pick up on page number 6 today, and we're going to look at what if we have 2 points that do not have the same x or y coordinate, all right? Same. What if they have different different x and y coordinates? So page number 6, we're going to pick that up here, and we're going to see an illustration. So we're going to look at the top of your page here. Okay, you're going to see a coordinate plane. We're going to quickly walk through that and see how we come up with the distance formula for when we have different x and y coordinates. Okay, so suppose we find the distance between A and B, okay? So we need to find the distance between A. So A is going to be, let's see here, -4, -1. So we're going to call this A, okay? -4, -1. And B is 1, 5, okay? We'll call that B. And this is -4, -1. How do I find the distance between these 2 points. Now, it's very important because, again, not very simple. It's easy if, if we have the same y coordinate or if we have the same x coordinate. But since we have different coordinates, how do we do this? So we're going to use the Pythagorean Theorem. We're going to create a right triangle. And so looking on the page there, and so if we draw AC parallel to the x-axis and BC parallel to the y-axis, we form right triangle ACB. So here's what that's saying. We're going to go right from here, okay? Actually, we'll just connect that. All right, so we're going to form a right triangle. So again, this is parallel to the x-axis right here, and then this one is parallel to the y-axis. We form a right triangle right at this point here, okay? We're going to call that C. We're going to call that C. So, now, how do we find the length of a side in a right triangle? Which special formula do we use? The Pythagorean Theorem. That is correct. You see, by using the Pythagorean Theorem, we know that AB squared equals AC squared plus BC squared. Now, let's walk through that, okay? We know that, obviously, the Pythagorean Theorem is, right, C squared equals A squared plus B squared. So we're going to say, right, what's the hypotenuse in this right triangle? It's opposite the right angle. So AB is the hypotenuse. So we're going to write it as AB squared equals, right, then our leg. So AC squared and BC squared. Okay? So there's our Pythagorean Theorem. Now, obviously, we want to find the square root of both sides. We want to remove the exponent on this side. So we're just going to simply go like this. Okay? And this gives me AB equals AC squared plus BC squared. Okay? So basically what I would do is I would square both of these terms, then add them, then find the square root of that, and then we would get the length of AB. So now let's go on one step further, okay? To find the coordinates of C, now right now we have the coordinates of A are -4, -1. We have the coordinates of B are 1 and 5. To find the coordinates of C, here's how we do that, okay? Let's read a little further. To find the coordinates of C, take the abscissa of B and the ordinate of A. Okay, the abscissa is the first term. So take the first term of B, okay, put that there, and then the abscissa of, the ordinate of A. So the ordinate is the second term, and there we have the coordinates. Obviously, we have, mine is a little off here, so let me correct that so it matches, okay? Okay, so -1, -1. Okay, now I'm off just a little bit, but we'll make it work here. Okay, so now, how do I find, now, notice, let's go back to what we learned yesterday. How do I find the distance between two coordinates that have the same y number, same ordinate? So now notice if you look at A and C, right? A and C, look at the ordinate. So they have the same y value, so -1, -1. So I would use the distance formula, x2 minus x1, to find the distance between these 2 points. Okay? And then, okay, since, again, look at B is 1, 5, okay? Since the abscissa is 1 here, and the abscissa is 1 here, right? That's the x value. And if the x values are the same, how do I find the distance? So y2 minus y1. So I'm going to find the distance from here to here. That'll give me the legs of my right triangle. And then I can simply find the distance between A to B. So let's quickly do that, all right? So D equals, all right, so we're going to go A and C here. So since we have our y values, our ordinates are the same, so we're going to go x2 minus x1. So x2 minus x1. So we're going to go 1 minus -4. And we're going to have just 1 plus 4. And the distance would be 5. Okay? Now, let's find the distance for from B to C. Okay, since we have the same x coordinate, the same abscissa, what we want to do now is go y2 minus y1. So y2 minus y1 is negative 1 minus 5. All right, so negative 1 minus 5 would be the absolute value of negative 6, which would be 6. There's the distance between BC and AC. Now, how do I find the hypotenuse? I'm going to plug it into the Pythagorean theorem. So here we go. Ready? So we know that the Pythagorean theorem is going to be AB equals, okay, the square root of, okay, what's AC, class? 5, good, squared, plus BC, which is 6 squared. All right, and so we have 5 squared plus 6 squared will be 25 plus 36. I'm going to have to erase this. Just don't have the room. 25 plus 36. And then 25 plus 36 would be 61. And then once we find the square root of 61, you'll find that the answer is 7.81. So the distance between A and B is 7.81. So we're able to find the distance between 2 points without having the same x or y coordinates. And again, we use that by using the Pythagorean theorem. Now, would you look at the note on your page there? You'll see the note in the middle of your page. The note says distance cannot be negative. The distance cannot be negative. Therefore, any answer that is distance will be positive. For decimal answers in this page, we're going to always round off to 2 decimal places. Now, look at Theorem 102. You want to highlight Theorem 102, you need to memorize Theorem 102. So the formula for the distance between 2 points, again, the difference is, okay, we have a different x and y value. Okay, so if we're looking for the distance, we have the same y value, we use this one. If we're looking for the distance that has the same x values, we use this one. If we're looking for the distance with a different x, y value, here it is. Distance equals, notice, okay, the square root of, okay, x2 minus x1 squared plus y2 minus y1 squared. Okay, now can I draw your attention to the board? You see here, right? x2 minus x1 and y2 minus y1. So the distance formula between 2 points that are different, we're just simply going to find the square root of x2 minus x1 squared minus y2 minus y1 squared. Let's take it one step further down below. Okay, I'm trying to lay some groundwork here, so hopefully we won't get confused. So I'm going to kind of erase this here. All right, just bear with me for a second. Okay. All right, we have, let's call this x. Now we're looking at the bottom of your page here. So we're looking at this, I'm going to explain this chart for you, this coordinate plane. So we have x and we have y, okay? And then we have, let's go, actually it's a little different. So I want to make sure I get the coordinates right. So let me do that right. Okay, so negative 3, 4, so here, all right, that'll be x. And then our y value would be 4. Okay, there's y. Okay, so we want to find the distance between x and y. Okay, so how do we find the distance between x and y? We're going to have to use the Pythagorean theorem. In order to do that, we're going to have to create a right angle. Okay, so we're going to go right down through here, through there, and then all the way down through here. Okay, and we're going to call that Z. Okay, there's our right angle there. Okay, so now we're going to call this, since this is our first term here, x1, y1. This is our second term, so x2, y2. And then the coordinates for z, again, will be the abscissa from y, so x2, and our ordinate would be from the first term here, which would be y1. Okay? Now we're going to plug this into our Pythagorean theorem. Okay, now this is how we come up with the distance formula. I'm just going to simply show you how we came up with the distance formula using the Pythagorean theorem, okay? And so we're just studying this proof of theorem 102. Now, we can construct a right triangle with the right angle at z. The coordinates are x2, y1. By applying the Pythagorean theorem, we can find the length of the hypotenuse xy. So, okay, we have xy squared equals xz squared plus yz squared. Find the square root of both sides, and we have xy equals the square root of xz squared plus yz squared. Now, okay, what are the coordinates for xz? Okay, we want to find the distance between x and z. So how do I find the distance between x, z? Again, we need to understand, look, pay attention here. I want you to look at this. Notice the ordinate. If we have the same y value, what formula do we use? Same y value. So we're going to go x2 minus x1 squared plus, okay, now we're going to look at the distance of these two. Notice they have the same x value, the same abscissa, so we're going to use the distance formula here. So y2 minus y1 squared. Does that look familiar? Here it is, Theorem 102. Theorem 102. This is the distance formula for finding the coordinates that have a different x and y value. All right, so let's work some of these together, okay? Let's practice here. Let's turn to page number 7, all right? Let's turn to page number 7. I'm going to try to make some room on my board here. Okay, here we go. Let's work together. Page 7. Page 7, we have, okay, here's our coordinates. We have 5, 9, and we have 2, 3, okay? So let's find the distance between these 2 points, these 2 coordinates, okay? Let's find the distance. We're going to use, now since, look, okay, we have different x and y values, so we're going to use this equation here, so the distance formula. So all we're going to do is plug in our numbers, our values. Okay, class? x2 minus x1. So x2, right, obviously, if we're going to just label these so we can see the difference, okay? So x2 minus x1 would be 2 minus 5 squared, okay? And then the second one will be y2 minus y1. So we're going to go 3 minus 9. All right, let's do our math. Okay, so 2 minus 5 is negative 3. Very good. 2 minus 5 is negative 3. Plus 3 minus 9 is... Now, again, you could combine these 2 steps, you know, if you use your calculator in your mind. I'm just going to kind of work these out so you see each step, okay? So negative 3 squared. So negative 3 times negative 3 is positive 9, and negative 6 times negative 6 would be 36. We have the square root of 45. The square root of 45. So make sure we read our directions here. Our directions state that we're going to just simply leave all of our answers into 2 decimal places, so round them off to 2 decimal places. So find the square root of 45, which you should get 6.71. 6.71, all right? So this is just so basic. All we're doing is plugging in and chugging out the answer. So be careful with your calculator work. Okay, let's do number 3. Let's do number 3, okay? We have our two coordinates are going to be 2, 8. And we have, oh, I'm sorry, that's number 4. We're doing number, oh, wait, I'm sorry. We did number 2. Let's do the evens together. So I want to go do number 4. So number 4 would be 2, 8, and -8 and -2. Okay? Again, so you don't get confused, sometimes I often label my coordinates so I don't get confused there. So let's plug in the distance formula and let's solve, okay? So D equals the square root of, all right, x2 minus x1. So x2 is -8 minus x1, which is 2, okay? Squared plus y2 minus y1. So -2 minus 8 squared. Okay? And get your calculators out. Let's work on these together. So -8 minus 2, we have -10 squared plus -2 minus 8 is -10 squared. Again, I'm taking extra steps, so again, a lot of these steps you could simply combine to simplify, but -10 squared is 100, plus -10 squared is 100, and so 100 plus 100 is going to be 200, and the square root of 200 is simply going to be 14.14. So finding the distance between 2 points, or excuse me, finding the distance between coordinates that do not have the same x and y value. All right, let's do another one together. Let's do number 6. All right, we'll do one more and for practice, and then you guys can go on. Okay, so number 6. Let's go. We have -3 and 9, and we have 2 and -7. So again, if you like to label them, this way you don't get confused, okay? So D equals the square root of, okay, x2 minus x1. So x2 is going to be 2 minus -3 squared. Be sure to keep track of your signs, okay? Do not lose sight of your signs here. Plus y2 minus y1, which is -7 minus 9 squared. All right, simply let's calculate these together. So 2 minus -3. So we know that's 2 plus 3. So we have here 5 squared plus -7 minus 9, class, would be -16 squared. Okay, so 5 squared would be 25. -16 squared would be -16 times -16, which would be positive 256, which gives me the square root of 281. So punch in your calculator and solve for the square root of 281, and that's going to give you the answer of 16.76. All right, so pretty basic, pretty straightforward there. Again, if you like to do those additional practice, okay, to kind of warm up, make sure you copy this work down, and so this way it becomes a good study pattern for the problems you're going to do later on for practice and for the checkup, okay? Okay, let's turn the page. Let's turn to page number 8. Page number 8. All right, so page number 8, extra practice there. You guys can continue to do that. Just apply some of these, and you're applying the distance formula to solve for that. So we're going to skip page number 8 and then do page number 9, okay? We're going to pick up page number 9, the midpoint formula. Does anyone remember what we learned about the midpoint? The midpoint divides a line segment into 2 equal or congruent parts. Very good. And so if we have 2 points, okay, the midpoint would be halfway between them. And so in order to find the midpoint, if we're looking for, again, let me draw our coordinate plane here, okay? And so here's our origin at 0, our y-axis, our x-axis. And so here we have -2, 4. Okay, so -2, 4 would be right here, okay? So -2, 4, okay? And then we have 6, 4, okay? So 1, 2, 3, 4, 5, 6, okay? All right, we're going to go 6, 4 here, okay? We can find the midpoint between those two marks there, okay? And so since it's parallel, notice here's the x-axis here, so this line would be parallel to the x-axis. And so if we're looking for the midpoint, all right, for a line that's parallel to the x-axis, simply we're going to divide the line segment by 2. So we would go x1 plus x2 divided by 2. All right, midpoint, half. So we're going to divide it by 1/2. So x1 plus x2 divided by 2. That gives me the midpoint of a line that's parallel to the x-axis. If we have a line that's parallel to the y-axis, and so again, I'm referring to your Cartesian plane here, your coordinate plane on page number 9. And so if we have, okay, this is 2, 2, and then we have d, which is 2, -8. Okay, all right, so 2, -8. Notice the line is parallel to the y-axis. And so if it's parallel to the y-axis, then we're going to go y1 plus y2 divided by 2. So the midpoint, if it's parallel to the x-axis, it's x1 plus x2 divided by 2. If it's parallel to the y-axis, it's y1 plus y2 divided by 2. Now, look at Theorem 103. You want to highlight Theorem 103. Very important. This is a formula that we want to memorize here. The midpoint of a segment joining the points x1, y1 and x2, y2 is the point x1 plus x2 divided by 2 and y1 plus y2 divided by 2. This is called the midpoint formula. So I'm going to write this over here. Midpoint, okay, formula. Again, I'm going to write this over here. Erase this. So our midpoint formula is going to be m equals x1 plus x2 over 2 and y1 plus y2 over 2. Okay? And that would be our midpoint formula. So if we're going to find the midpoint of any number, of any line, okay, between two coordinates, this is the formula that we're going to use, okay? So let's turn to page number 10, and let's finish off with this, and you can take your checkup, okay? So, look at the top of page number 10. Find the coordinates for M, the midpoint of AB, okay? So we have AB, we have 3, 4, just write this on the board, 3, 4, and we have -1 and 8. Let's find the midpoint. So how do we find the midpoint, okay? So obviously we're going to take our formula here, all right? So we got to find our midpoint between these, so we're going to just plug in and divide by 2. You say, why do we have two sets of formulas here? Well, remember, our coordinates are made up of two numbers, correct? Our coordinates are made up of the x number, or the abscissa, and the ordinate. So naturally, I got to find, right, the x number. So I find x1 plus x2 divided by 2 gives me the first number in my coordinate pair. And then y1 plus y2 divided by 2 gives me my y, the ordinate in my ordered pair of numbers. So let's plug in and simply chug here. So m equals, okay, x1 plus x2. If you need to mark them again, just so you're not confused here. All right, x1 plus x2 would be 3 plus negative 1 divided by 2. All right, that would be the midpoint of x, and then the y would be y1 plus y2. So y1, would be 4 plus 8 over 2. Now let's just simply figure them out, okay? All right, so we have 3 minus 1 would be 2. So 2 over 2 equals 1. So, okay, our x value is 1. And let's find the y value. So 4 plus 8 would be 12 over 2. 12 over 2 equals 6. And there's your coordinate there, 1, 6. So we need both of these formulas. The x plus 1 plus x2 over 2 gives me the x value. The y1 plus the y2 over 2 gives me the y. All right, so 1 gives me the abscissa, 1 gives me the ordinate. Okay, let's do number 5 together. Let's do number 4. Let's do number 4 together as we get ready to wrap this up. Okay, so number 4, we have, okay, negative 2, 8, and negative 4, 2. What's the midpoint? Okay, what's the coordinate? What are the coordinates that would be the midpoint between A and B? So let's plug and chug here. So x1 plus x2. All right, so negative 2 plus negative 4 over 2. All right, and then the midpoint of y would be y1 plus y2. So y1 is 8, y2 is 2 over 2. Okay, negative 4 and, negative 2 minus 4 gives me negative 6 over 2. Negative 6 over 2 reduced gives me negative 3. All right, so there's my first coordinate, negative 3. That's my x value. Now y would be 10 over 2, which would be 5. That gives me the y value. So the midpoint would be on the graph, on the coordinate plane, negative 3, 5. Negative 3 at precisely that coordinate, okay? And so we're going to end there. What I'd like for you to do is finish page number 10 for practice, and number 7 as well for practice. And then I'd like you to take the checkup. And so you're going to do the checkup. And for the checkup, you're going to do numbers 1 through 15. 1 through 15. And then you're going to do the even numbers on the bottom of page 11 and page 12. 1 through 15. And then the evens 16 through 34. Okay? And so hope you have a blessed day. We will see you all tomorrow, Lord willing. Bye-bye.